All right. Okay, let's go, guys. We have a lot of work to do today. First things first, let's get those calculators out. Yesterday, your delinquent teacher was having you figure stuff out that your calculator will figure out for you. So figuring out is good. Uh-oh, you okay, Caitlin? Figuring out is good. But since you bought this calculator, we might as well use it. So get your notes out. Page 1. We already did it, I know, but we're going to do it again with the calculator. Remember these problems were a little confusing when we were trying to figure out what the equation was, what the graph was, from just this set of points. So here is what I want everybody to do. And I get really cranky when you don't follow along. So I need everybody, whatever we're doing, Sam, yep, eating our fruit snacks, we're gonna put those down for a minute. And we're all gonna get our calculator out. And we're all going to do problem number 5. Now, we already did it, and if you were taking good notes yesterday, then you know what the answers to number 5 are. And now we're gonna let our calculator do it. Yesterday, remember, we did it by things like y-intercept, slope, that kind of thing. We were looking at clues within the numbers. Now we're going to let our calculator actually do the problem for us, okay? So, please just stay with me. Even if you think you already know what to do, I hope you do, but just stay with me in case you don't. All right, so the first thing I'm going to do, I'm looking at problem number 5. I'm going to go to Window and look at the X's in problem number 5. The X's in problem number 5 go from 1 to 6. So I always give myself a little cushion on either side. So maybe I'll go from 0 to 8. There's nothing magic about those numbers. I just want to incorporate the X's on my paper. So X min 0, X max 8. Everybody got that? When I go to another problem, will I need to adjust that? Yep, depending on what the data is in the new problem. Okay, now do the same thing for Y. Y min and Y max. Look at your Y's. Maybe 0 to 40? Or 0 to 42 if you want to give yourself a little extra cushion, something like that. Okay, so that's the first thing I do. Because in a minute, I'm going to put those numbers in and I'm going to hit graph. And you're not going to see those points unless I made my window match the points. Got it? Okay. Now, I'm going to go to Stack. You have a button called Stack. Okay? And I'm just going to, first option's Edit. I'm just going to press Enter. Did you come up with L1, L2? Does anybody have numbers already in there? Or are they blank? Blank? Long or blank? We're all good. And we're going to do another example, and then at that point I'll show you how to try to get it out. Got it? I want you to enter your X values in L1 and your Y values in L2. So you just type them in and press enter. Okay, just type them in. So X's are L1, Y's are L2. So basically what you're doing is inputting ordered pairs. Where's your calculator, Elijah? Okay, that's not a good place. Yours isn't charged. Okay, honey? It's like not having a calculator. It's not charged. Okay. Now we're getting our X's and our Y slice in. Press that. Get it. Keep that stuff in. Okay, we got them in? As soon as you have all of your data in, then go ahead and hit second quit. Second quit just takes you back to that home regular screen. Okay, because we're done. We're done putting the data into the edit mode, okay? Now, go to where it says stat plot, right above your Y equals button. So press second stat plot. And right now, probably all your plots are off. Does it say plot 1 off, plot 2 off, okay? You want to turn plot 1 on. So, just press, plot 1 should be highlighted, just press enter. And then hit on, okay? And then hit graph. Now, what you should have seen, what you should have seen is dots. Those are the points that we just put into the calculator. Okay, everybody got the picture? So now we know, without hand plotting, which is what some of us were doing yesterday, which is fine. Now we know this isn't a line, this is a parabola, right? Part of a parabola. Would everyone agree? And what kind of an equation is a parabola? X squared, quadratic, right? So now I want you to go back to stat. And remember, to put our data points in, we stayed in edit. But now we're going to go across to calc, because now we want to do something with the data that's in there. Edit means we're just changing the data, put it in there. Over to calc. Now, do you notice in your list of options there, you have quadratic? Get it, that's the one you want. Now, your various calculators will require you to deal with this in various ways. Yeah. Okay, so it's L1, L2, just take calculator. If you have a newer calculator, just go down to calculator. If you have an older calculator, usually just, yeah, you need calculator. Okay? Now, go to calculate and hit enter. And it's going to give you an equation. Now, it tells you at the top, this is the format of the equation, which of course is true, it's x squared parabola. But then it gives you an a value, which is -1, a b value, which is 0. Now my calculator says -2.7 e -12. Anybody else to say that for me? Okay, that's scientific notation times 10 to the -12. Tell me about a number that's times 10 to the -12.
Very close to 0.
0. When that pops up, 0. 0. Every time that pops up. And then my C is 40. So my equation is -x squared plus 40. That is exactly what we came up with yesterday. Only now the calculator did it all by itself. Okay? Now, we're going to do another example. So if you got lost in there somewhere, pay close attention. Get your homework out. Your homework, 1.1. And we're going to do problem number 1.
Woman's frozen food.
to always say, why do I have to graphic? Why don't I just go straight to stat edit? Here's the thing. We knew to choose quadratic. Remember in that list of options we had? We knew to choose quadratic because why? We looked at the points and they made a parabola. If you don't know what shape you've got, then you don't know which option to pick. So we're always going to stat plot first. All right, so here we go. First step, window. What do you want to do with your x's this time?
0 to 25.
What are we doing?
0, we're doing number 1 in the homework. I'm going 0 to 30. You go wherever you want. I'm going 0 to 30 on my x's. And then what about my y's? I can do 0 to 800, that'd be kind of big, but it'll work. I'll do 0 to 650. Okay? Now, again, there's nothing magical about those numbers, but I have to have it set up so that the points are inside that area. Is everybody with me on that? Everybody understands that? That's going to be step 1. Okay? I don't want anybody coming up crying to me saying, I don't see anything. Probably if you don't see anything, it's because you didn't do this. Always do this first. All right. Now, let's put our points in. So we go to Stat, Edit. Now, everybody should have stuff in L1, L2.
Yeah.
You can type over those if you want. Let me tell you how to clear them in case you have too many to type over. If you highlight L2, so take your arrow, button up, so L2 is highlighted, and then you press clear and enter, it will clear out that column. Then go over to L1. So L1 has black on it now, it's highlighted, the heading, the headline. Hit clear and enter, and that wipes out that column. All right, did everybody get that? If you didn't, when we leave for lunch, I'll help you with that. All right, let's put in our data points. We're on the homework now. So put in your X's. We're doing the homework problem. Together, we're doing the homework problem. Putting in our X's and our Y's. No, it depends what the shape is. You gotta look at the points to see, because sometimes they make a straight line. Once you get your last data point in, go ahead and second quit. And then you go back to, and then you hit graph. Gotta hit graph so I have a shape. Did you get a parabola opening up this time?
Yeah.
So Charlie said, is it always going to be option 5 quadratic? And the answer is no, but it is again, because we have a parabola again. Parabolas mean quadratic. So we're going to go to Stat, Calc, down to quadratic. And what is your equation for your homework? You were supposed to come up with an equation. Y equals x squared plus x, x squared plus x. Remember, this is your format, and it said A is 1 and B is 1, and C is 0. So x squared plus x is your equation.
You don't have to put the 0.
You don't need to put plus 0.
What? Give me the. Wait, how do you do that? How do you do that?
Stat.
Yeah.
Calc. Pick option 5. It's quadratic. It's quadratic. You graph the picture so you could see a parabola, so you knew it was quadratic. Kids, if you do your plot, if you graph it, and the dots come out in a straight line, then you're not gonna pick option 5. You're gonna pick the linear option, right? Y equals, however it says, ax plus b or whatever. Linear regression. You're gonna pick that one if it's a line. Now, right now, ours are all gonna be lines or parabolas. The calculator can handle many other things, but right now, we're gonna either have a line or a parabola. And if you can't tell from the data, then you have to plot them, either by hand or with the calculator, and check to see what shape you have. Okay? Now, that's the only one in the homework. So put that aside, go back to your notes, and with your partner, let's see. With your partner, do problem 2. With your partner, do problem 2. Oh, maybe not. Wait a minute, not 2. No, in the notes.
Page 81.
Yeah. But wait, I want to get it. I want to talk about How about 1? With your partner, do number 1. Do number 1 on the calculator, okay? So we're trying it one more time. Alright, I'm gonna come around while you're working on this. You know what you're doing? Okay? You know what you're doing?
Yeah. I got my wrong.
All the way. You guys got it? So when you did plot the points, were they aligned? Yep. So this time when you plotted your points, guys, did they make a line?
Yep.
So did you linear rag?
2x.
Well, I was
Come on. Oh, yeah, you just got
You guys got it? So did you come up with the same equation we got yesterday?
Yeah.
Got it?
No, you're good.
It's not the quadratic.
Stop! No, we need that.
Yeah, it's just not always.
Yeah, I'm looking at those.
Squared plus b squared.
All right, so everybody's got this now figured out, right?
Yeah.
All good. Okay. Thank you for that. That's good. Glad you got that taken care of. Now, since we're a little bit, off track anyway. Let's talk about, you don't need to write this down unless you want to, but I want to do one more problem like we did yesterday, where you have to talk about all of the characteristics of the function. So let's consider this equation. Negative x. What does that look like? You should know. That's a parabola, but it is okay, so here's my picture. Now, let's answer these questions. Is this continuous? This is review from yesterday. Continuous? Yes, because the whole thing can be drawn without picking up my pencil, right? Would you say it's increasing or decreasing? Okay, we don't say both. We say, okay, from negative infinity to 0, it is increasing. And from 0 to positive infinity, it is decreasing. This is called function analysis, and is what calculus students do. They look at pictures and talk about it. Would you say this is bounded above? Yes. It's bounded above.
Wait, can you explain it?
This is as high as it goes, right? Boundedness is up and down, so we're looking at the y's. Is it bounded below? No, because what happens, what do these mean? Forever? So there's no floor, this just keeps going. So therefore, can we say it is bounded? No. Remember, to be bounded, you have to be above and below. All right. Does this guy have any asymptotes? No. Does he have a maximum and or a minimum? He has a maximum at the point 0, 0. Does he have any symmetry?
Yes.
Yes. All parabolas have symmetry, right? All parabolas do. This would be the line of symmetry. So it is symmetric about the line, x equals 0. X equals 0. What is his domain? Negative infinity to infinity. That means all reals. I heard somebody say all reals. But now we're big kids, so we're going to say negative infinity to infinity. What is the range?
0
to negative infinity to 0.
Very good. Negative infinity to 0, and 0 is included. Does this thing have any zeros? Wait. Zeros are x-intercepts. Does it have an x-intercept? Yes, it does. It has a 0 at 0, 0. If the parabola had been moved over here, then the 0 would be here, right? X-intercept, where we cross the x-axis.
So when we get here, you want us to put the x amplifier?
Actually, it really doesn't matter. It's probably best in terms of the graph to go ahead and put the point. Okay, so now we got a couple minutes. We're going to get started on the next page of your notes, which is 11A, and it's called supplemental symmetry notes. Here we go. Our special symmetries are y-axis, x-axis, identity line, I'll put that in parentheses, this is the identity line, and the origin. These are our special symmetries. So certainly, parabolas can have other symmetries. Absolute values can have other symmetries. But these are the special ones. I'm gonna tell you what the tests are, because at some point, like question A, we're gonna have to determine if this equation has any special symmetries. Okay, so here's what you do. If you are testing for symmetry about the y-axis, you change the sign on x. So in other words, for my equation, it would be y equals 3 times negative x, or y equals negative 3x. That's how I test for symmetry to the y-axis. I change the sign on x. Now, did I get, when I did that, when I changed the sign on x, did I get an equation that's exactly the same as my original? Is that the same as that? No. So this one has no symmetry about the y-axis. Okay? This particular equation, because if it has symmetry, when you get your new equation, it matches the original. How do you think we test for symmetry about the x-axis? Change the sign on
Nice. Oh, why?
y. Change the sign on y. So, negative y equals 3x. Just make y negative. Is that the same as my original equation? Nope. No symmetry there either. To test for the identity line, you switch y and x. So in other words, instead of having y equals 3x, we have x equals 3y. Believe it or not, sometimes these actually match. This one doesn't. Because doesn't this one say y equals x over 3? Which is not my original, so that's a no. And then, the origin. You change the sign on both. On both x and y. Okay, so if I did that, always go back to your original. If I change the sign on x and y, I would have negative y equals 3 times negative x. So negative y equals negative 3x, which is y equals 3x when I clean it up.
Yep.
And that matches my original, so this one is a yes. So the question said, find the special symmetries for y equals 3x. The only one is symmetric about the origin, which makes perfectly good sense because y equals 3x looks like that. And those points, if we go across the origin, wouldn't those points map right onto these? Yeah. All right, we will do the other 3 after lunch. So go ahead, back in your seats at 45. No dilly-dallying. We have a lot to do.